Hey everybody. So I'm going to talk about realizing the Filecoin vision. Raise your hand if you were in Singapore for this. A few folks. Great. So this will be some amount of the same content, but a lot more expanded in other areas that we didn't cover. And the talk from that time is also available online for those of you who want to see the expanded parts in that one. Cool. So this is going to cover 3 sections. The Filecoin mission and vision, the Filecoin economy and businesses, and then working backwards from success. So we're going to go through kind of an exercise of visualizing success in the future, and then working backwards to establish different requirements for the system and the network. So there's like I mentioned, there's a talk earlier. It's on YouTube. You can go check that out. This one goes deeper into the mission, so I'm going to just go quickly in that part on this one, but that one goes much deeper into it, so you can go check that one out. As we know, Filecoin is a very large-scale system. It's a combination of many different components that work together to build up this large-scale service and platform and decentralized ecosystem. The mission is to create a decentralized, efficient, and robust foundation for humanity's information. This is a long-standing mission from the very beginning. It's been about data storage all the way through. It's almost going to come into like 10 years of like Filecoin things. By the way, large projects take a while. Decentralization is key in order to build an internet platform and ecosystem that respects users' rights. There's all kinds of things that feature in that decentralization question. Things around there not being centralized intermediaries that control the network. Things about being able to use economic incentives to be able to drive the behaviors in the network, using cryptography instead of trust, and so on. We need efficiency, so that means we need to get very close to the kind of physical, whatever is physically possible given modern technology, and we need the network to adapt over time to reduce kind of any other kind of extraneous, not extraneous, but any other kind of overhead costs that are due to the network itself or the protocol itself that are above anything else. So we need to get high efficiency. We also want to build a large-scale marketplace that enables people to get certain cost reductions that are available to various parties that are not available to maybe large-scale centralized players. And this means also efficiency in terms of all of the user SLAs, right? So efficiency in terms of how storage works, efficiency in terms of retrieval, efficiency in terms of all of the control plane overhead. We want robustness, which means we need to be able to have an available network. It needs to be partition tolerant. I've been probably the only person talking about partition tolerant blockchains for a very long time now. We're finally getting close to that. Users need to be able to keep their data safe. The network needs to be able to robustly store that data and archive it for the long term. And we need to be able to tolerate massive scale failures. The internet was designed to be able to tolerate extreme circumstances. We want this kind of network to be able to do that, to make a cloud that's fully resilient in the way that the internet is. We also want to be able to protect against massive scale attacks or catastrophic events. So think of like things like natural disasters or various kinds of attacks. We also want to make sure that robustness supports an information use case where, today like information on the internet isn't really like information in paper. In paper you can write something, put it somewhere and walk away and it's still going to be there. In the location address web, that's not the case. You can write information, but you're required to maintain a running service providing that information at all times. We want to get to a point where you can store information on the network, store applications, store entire sites, large troves of information, and then walk away. And if the community finds that information valuable, meaning economically valuable, it'll keep storing it over time. We want Filecoin to be a foundation. We want it to be a platform for many other kinds of applications. We want this to be a dependable system. That means it needs to get both flesh out a whole set of capabilities. It needs to be programmable. It needs to have all kinds of layers to enable many different kinds of use cases. And we wanted to store humanities information. And what do we mean by humanities information? We don't mean the intersection of what we all think is valuable, because the broader the community gets, that intersection gets closer and closer to zero. We mean the union of what we all think is valuable as humans. We mean if humans care about maintaining this data and keeping it, we want to be able to store it on Filecoin. This means we want a platform to become a huge fraction of the storage of the whole planet. We want a decentralized network that can support all kinds of applications. Like when you think about the things that you use in your phone or your computer today, think of those systems using this network eventually. The cloud took about 30 years. We'll see that in a moment. We'll go through that story. The cloud took about 30 years to get there. Decentralized networks are going to take kind of similar kind of time scale, but that's the long-term plan. And now, of course, like the one caveat here, the only piece of data that we don't care about storing is like malicious data that's just trying to steal the incentives. So like that's what Fil+ is about. It's just about like removing that malicious use case. But it's really about storing all of humanity's data. So again, it's a large-scale system, all kinds of components. Many people work across many different areas. And it is a system built out of a bunch of other protocols, right? So Filecoin is leveraging all kinds of other systems in order to be able to do what it does. And so that means our community of developers is working with a bunch of other communities and other projects. And so we have overlaps across many of these things. There's probably a bunch that I didn't even put here, but even things like the web standards or the IETF internet protocol stack to many different kind of blockchain systems, cryptography systems, all the IPFS universe of things, things like lib2p and so on. Cool. So quick reminder of kind of the broad strategy that we've been following. Step one is to build the world's largest decentralized storage network. We've basically achieved that by building a massive scale storage network. We are now working on onboarding and safeguarding humanity's data onto that network, and we've been onboarding a massive scale of data in the last year, which has been phenomenal to see. And step three is to bring compute to the data. That means adding programmability in many different kinds of ways. Step one is to bring compute to the chain itself. We did that with FVM. The next steps there are to bring compute to the data through things like compute over data networks, and then to scale the chain itself to build larger scale applications through IPC. Cool. So that's again, you can go watch the other talk for a more expanded version of that. Let's talk about the Filecoin economy. So the Filecoin economy is a large-scale system. You can think of it as an export economy, similar to a country or something like that. There's some production going on in that country, in that environment. There is value being produced and being transacted in that economy. You can think of the transactions within that economy as helping in the production of goods and services within that economy. You can think of exports from that economy to other economies as the selling of a service to the rest of the world for Filecoin. And so that means some other currency is being exchanged for Filecoin in order to buy that service. Or you can think of exports. Exports are when participants have to buy some other goods and services produced by other economies and import them into this one. And so you can think of that as like the CapEx or OpEx of various companies. And so thinking about this model, when parties use Filecoin as a unit of exchange, or they use it as gas in the transaction structure, that means value being moved and transacted and created within the economy. When you're selling the goods and services that we're producing to the rest of the world in Filecoin, you're then growing the economy by exporting the service. And when you're having to sell Filecoin in order to buy other things like food, hardware, and so on, you're then importing other things, and you're into the economy shrinks in that moment. So you can think of the different economic changes as the economy grows when there's internal transactions happening, and that the number of transactions there is growing. The economy also grows when you're exporting value, meaning exporting goods and services to the rest of the world, and the economy shrinks when you're importing other goods. So let's visualize this kind of model, you can think of this as these 4 sections. I mentioned 3, but I split up the transactions into 2 sections. You can think of the internal businesses as being able to just kind of, again, transact within in Filecoin within the economy. You can think of consumption as the process of spending and consuming Filecoin to use services within the network. You can think of the exports as selling the services. The arrow here is going in, which is the opposite of what would be normally intuitive. When you think of an export, you think of something going out, but in reality, the value is coming in, and you can think of imports in the other direction. So I want to talk about exports here. So think of Filecoin as an economy connected to a bunch of other economies and other systems and services, and think of the Filecoin economy being successful by tapping into those other systems and those other economies, selling the service, the set of services and goods that we're producing to those other economies. And so you can reason about what are good strategies and plans by looking at those other economies and the sizes of them, right? So for example, a lot of us are working on Web3 storage market things, which are super valuable, and we think in the long term they're going to grow tremendously, and over time that market is going to grow to rival the other ones and potentially be larger. However, that's not the case today. That market is very, very, very small today. And so while it's key to build those components and sort of win in that market, it is not sufficient. The Filecoin economy is much larger already than just the Web3 storage market. So now we have to turn our eyes to many other markets, things like the broader archival storage market, the CDN market, the cloud object storage market, the consumer cloud storage market, and there's a bunch of other ones, right? And each one of these is going to require different kinds of feature sets, different kinds of systems and services. And so we have to kind of plot good strategies to be able to do well in a bunch of these. So for example, the archival storage market made sense given how POREP and sealing works today. The CDN market makes sense once we can scale up the retrieval market networks to be able to provide very fast retrieval. Cloud object storage market is going to make a lot more sense once we're able to have really fast retrievability from SPs or from RPs, and that is in place. Consumer cloud storage market might actually make a lot more sense now than I think a lot of us have been thinking about. So then think of kind of establishing various different participants across the network in their own way, produce some service or business, and then sell it to these other economies. You can think of the Web3 storage market segment. Again, it's a really important one, but it's very small still. So you can think of this as primarily static assets, things like application front ends, NFTs, and so on. Off-chain data, things that are being stored from other chains. So whenever some chain links out to some object. You can think of the storage of the chains themselves. So think of all of the state trees and all of the blocks of those chains. You can think of data availability for the scalability of other chains. So there's all kinds of kind of sub-segments or sub-markets in that larger market. Really, really valuable, and it's one where there's a very significant storage premium. Offering storage in this market comes with a very high premium because there's not that many solutions that enable the decentralized feature set. But again, very small compared to the other markets. So we have to succeed here, but the success case here is in the future, in that market will have to grow quite a bit. The next market, which is another one that a lot of us are working on, is just the kind of more mainstream storage market segments. This means things like cold storage and archival, again, object storage, consumer cloud storage, large-scale scientific data sets, government data sets, and so on. This is where the bulk of the data in the world is, and here I'm using this grouping to kind of mean these 4 large big markets, and so this is where winning in this area earlier is key in order to bring a very large economic flow into the network. And so for this one, I think it's very useful to think of the traditional market disruption frameworks. So you can think of, so let's use the story of the cloud as an example. So the cloud started getting built in the 90s. I mean, people talked about it before in the 80s, and maybe depending on how if you squint at it, 70s and before. But it really kind of got its large start in the 90s. However, the very big impact started happening in the mid 2000s, right? So it took about 10 years-ish of many different products and systems getting rolled out for the infrastructure to get in place to then be able to have what we normally today think of as cloud computing, as like being able to have some products like EC2 or S3 or the various other clouds. And the cloud, like many other key paradigm shifts, had to replace some other paradigm that was in place before, that was the incumbent paradigm, right? So the on-premise hardware setup where most companies in the world and most groups in the world had to get their own data center space, they had to get their own hardware, they provision their own machines, run their own software, and maintain the whole thing. That structure had to be replaced by the cloud. However, the cloud selling point to most of the on-prem users was a new product with a ton of risks, not a lot of features. You lost a lot of the control over the system. However, it gave you some new kinds of things you could do, and it enabled a huge cost reduction. So in paradigm shifts, you require a cost reduction in order to start chipping away at the market and gaining market share to the point where over time you can then start displacing the incumbents. And so over time, over the 30-year time scale, the cloud eventually started replacing the on-prem systems. And nowadays, you can even have cloud products today that are much more expensive than on-prem solutions. You can hear nowadays of groups like Dropbox and others who are like, oh, save money by moving off the cloud to your own on-prem thing. Because now after building out a massive scale feature set, the cloud is really winning on features, not on cost reductions. But in order to get there, the cloud required that cost reduction to be in place for a very long time. So similarly, if we want to replace the kind of centralized cloud paradigm with the decentralized cloud paradigm, we need the same kind of structure. We need that significant cost reduction, and we need a key feature set that is going to drive some customers into this direction. It's worth noting the massive moats that centralized cloud has, massive economies of scale, large, with massive scale efficiencies, huge feature sets that have taken, again, 30 years to build out. So we're in the tens of thousands of features probably that these systems have. There's established business flows, so all kinds of companies and so on are used to using those systems. So you have to sort of convince them to switch over to something new. That's hard. And they have massive teams. Like these groups have large scale teams. So now what are Filecoin's advantages in order to kind of counteract this, in order to build something that is successful in spite of these challenges? First off, we have key differentiator features. These are feature sets that centralized parties can't easily copy. So this means kind of the commons-oriented view of data, content addressing, the smart contracts, permissionless innovation type stuff. Then, extremely important, we have that cost reduction thanks to the block reward. The block reward gives us the cost reduction that we need in order to beat out, to cause this paradigm shift, which is why the block reward of Filecoin is designed for data storage, not hardware, and why Filecoin requires that distinguisher between what's legit client data versus not. And then a key feature here, which is kind of harder to tap into, is not as concrete, is that we can have a scalable, permissionless innovation environment thanks to open source, thanks to running an open service, thanks to having a blockchain-powered service that enables a highly scalable network to then out-innovate those environments once we hit a certain level of momentum. So that means that once you can kind of accrue a level of utility and value in the network, you can then accrete over time lots of teams from around the world that will then choose to build that infrastructure because it's permissionless for them to just show up and do it. Think of it kind of like the financial rails of something like blockchains in general, and how easy it is to pick up these kinds of new systems and build your new kinds of platforms on top of it. And so through this, you can even get to a point where the centralized cloud systems might even join the decentralized cloud system, and you end up with like not just a strict replacement of paradigm, but instead upgrading the old paradigm and enabling those centralized cloud providers to become part of the decentralized cloud by adding those kinds of feature sets, by adding strong verifiability, by adding strong encryption, by adding all of these components, and then participating in the economic protocols that we're developing. That kind of thing is the sort of vision that takes a very long time to realize, but it's very possible, and it's what this project and many other projects in the crypto ecosystem and the Web3 ecosystem are broadly about. Cool. So the last two that I'll mention here are things like Filecoin applications in general. This has been super well covered in the broader blockchain ecosystem. So this means adding things that use smart contract transactions on chain, things that use gas and so on. Like that's always a great business component for Filecoin. And the last one that is similar to that, but I'll call out specifically because it's just so important, is to build L2s on top of Filecoin. So that means whole other networks that rely on the Filecoin network itself and its benefits to then do something else that's extremely valuable and extremely useful. So a good example of this is the Saturn network being able to do retrievability and so on, compute over data networks, data prep networks, object storage networks, all kinds of things you can think and model as L2s running on top of Filecoin. And so that is a kind of a really extremely valuable area of development. Also good business model. So turns out you can build a lot of systems as L2s. So again, have this picture in mind of the economy in the Filecoin economy growing by tapping into these other markets, offering an extremely valuable service, and exporting that value and then bringing value into the economy. Cool. So now I'll move fast through working backward from success. So this exercise is about kind of thinking about what sort of improvements and changes are needed in Filecoin in order to meet these kinds of goals. So first off, we have to establish some kind of market target. From that, we can approximate some characteristics. And so all of this is in the future, right? So you think ahead, 10, 20 years, something like that. You imagine some kind of target market size that you want to sort of capture. You then derive characteristics that must be true about the system at that scale. You then from there figure out system constraints, meaning how should the system behave in order to be able to meet those characteristics. And then that tells you, given where you are today, given where it must be in the future, what sort of improvements you need to build, and what kind of trajectory you might need to take, right? Because you can't just kind of start working on what it'll be like in 20 years. You have to plot some course over time, navigating, creating value along the way, creating a valuable business that enables a value flow that allows you to build up the product or technology over time. So we'll like do this a little bit quickly here together. So you can think of all storage in the world, and you can think of kind of saying, okay, great, like what fraction of all storage in the world do we want to store in Filecoin? You could say like all of it. You could say 50%. You could say 10%. You could say 1%. Here, for simplicity, let's just imagine 10%. That's not a super ambitious target, but it's also not unambitious. So it's kind of like a sweet spot in between. So let's kind of estimate those characteristics. So think of the scale of usage of storage on the internet across different timescales. And so, for example, the number of people on the internet is going to go from about 5 billion to 6 billion in the next decade and a half or so. And by the way, I used a lot of estimates here from the internet to plot out these charts. So I'm relying on internet estimates. The number of devices in the world, it's about 30 billion devices connected now. I think that's an underestimate. I think my sense is that there's likely many more. They're just not as well accounted for. But it's probably not a trillion. And And then if you take 10% of that, that means like 3 billion devices need to be connected to the network. You plot that out with a scaling over time, you get to in the scale of 5 billion, or if you want to be more accurate, probably 10 billion a year, 10, 15 years out. Then you can think about, say, the number of HTTP requests per day. So this is kind of what the network needs to be able to serve eventually, right? So this is a very hard one to estimate. There's a lot of parties don't disclose what kind of throughputs they actually do. It's kind of like tricky to estimate. But a very conservative low bound is something like about 100 trillion requests per day. I think the real figure is about probably 2 orders of magnitude larger, but let's say that it's just this. So that means that Filecoin needs to be able to serve, to get 10% of the market, around 10 trillion requests per day. That is way larger than we're capable of doing today. But that kind of gives you a picture. Now, if you plot it out, 5 years, 10 years, 15 years out, that figure grows over time. Now, of course, it'll take a while to get there, and so you have to kind of plot an intersect course over time to get there. But it means the protocols need to be able to support this kind of thing. If a protocol is not gonna, it's just like there's no possible way that it can like hit this, then that doesn't work. Number of data objects. This is a little bit trickier. However, S3 has like a really good estimate pointer that they say they store about 280 trillion objects, which is pretty awesome. If you kind of assume there's a few other services like that, very long tail of like much smaller things, and you take that again as a conservative bound, lower bound, you could get into like the 5 quadrillion objects or something like that. You can plot that growing over time, and you get into the scale of like a half a quadrillion objects now, going towards like one or two in the next 10, 15 years for Filecoin. So that means like that many objects are stored, and that means that many objects need to be accounted for. They need access controls. They need retrievability guarantees. They need creation and like deletion moments and so on. So we're talking about a massive scale of throughput, right? So this is not like the current deals on chain and the massive gas expense in that structure. We need a new kind of deal set of data structures that are way, way more scalable. This is why we're doing things like the IPC subnet scaling. Then when you think about like the amount of total data stored, humanity is sort of like in the zettabytes. We create a lot more than we store. So there's a huge amount being created. There's a huge amount of hardware being built and shipped, and then we store. The estimates here vary, but they're kind of around 8 zettabytes today. You can plot that growing over time, and so that means that the Filecoin network needs to get to storing, around 0.8 to 2 zettabytes in this time scale. So that's 1,000 times larger than where we are today. Which, by the way, where we are today was 1,000 times larger than we were 2 years ago, or something like that. So it's totally achievable. These orders of magnitude will be much harder to reach, but this is sort of the scale that we need to get to. And just to be clear, like if we don't get to this kind of scale, then Filecoin just isn't successful. It just becomes kind of this small thing that was kind of like a neat thing for a while, but like it gets falls by the wayside of the technology development pathway, right? So think of like, all kinds of technologies that are sort of like were cool and nifty for a while, but like didn't actually achieve market success. So plotting these targets, and you say, okay, great, like let's try and get 10%. We can drop those figures, make it a little bit easier. Those are the target characteristics that we need to be able to hit, and so those become design goals for protocol development in the long term. And from there, we can extract kind of more concrete system constraints. So that means like, things like this. We need to be able to scale the onboarding to zettabytes. We need writes of all kinds of sizes, tiny things, huge things. We need aggregation of things. We need collections like buckets, large file systems, all kinds of things. We need mutable writes to be easy. We need reads of all sizes. We need reads with very low latencies for those kinds of systems, right? 3 milliseconds, 30 milliseconds, 100 milliseconds, and so on, depending on where you are, where the client is, and so on. We need all kinds of storage media, different storage tiers, things like being able to leverage the actual hardware constraints. This means the chain itself must scale. We can't just do tens of thousands of transactions per second which, by the way, is already kind of like a large blockchain target, we need to be able to get to millions or billions of transactions per second, which is a very different target than what a lot of blockchains do. Again, this is why like the IPC hierarchical structure is built that way. And eventually, we need to get to partition tolerance, which in a blockchain seems kind of counterintuitive, but again, it's achievable with a subnet type thing. And we need things like storage certifications and all kinds of things. There's probably a much longer list, so this is just a stab at like saying some of the things that must be true based on this. It might be really useful for the community to build like a larger exercise like this to really flesh it out. And then from there, we can think of like what are the kinds of improvement trajectories that we need in order to achieve these system constraints. So that means, first off, like we're going to need a bunch of new pore reps. We need to be able to have pore reps allow fast retrieval. So that likely means that pore reps need to be in the latency model, not the cost model, because again, we need to be efficient. We likely also need pore reps tuned for the storage media. So it's kind of, we're currently using pore reps to turn SSDs and hard drives into tape. And like that's not a very efficient way to operate a storage network. Let's build pore reps that are tuned for the specific hardware in question and be able to actually sell that hardware at that rate, right? So that means sealing and unsealing at the rate of the hardware reads, not at hours. Deals must be, we need to be able to create deals of any size, tiny things, huge things, and so on. Deal size and expiration needs to be independent of the sector and so on. We need composable deals because we need aggregations and buckets and so on. We need these on-ramps to exist. We need to be able to write at really high throughput into a small thing that doesn't go on like on-chain on L1. And we need those kinds of on-ramps to work and scale. We need to be able to have indexing of all of this data. We need retrievability. We require verification of the retrievability. We need likely incentive structures to connect to the retrievability. We need extremely fast retrievability, which means regional caching, and it needs retrieval markets and all that kind of stuff. We need the chain to scale. We need compute over this data because this is not sufficient to just have a storage network. You need to be able to bring localized compute to where that data is. And you need access controls mapped to all of these kind of huge amount of small objects. This last one is kind of maybe less familiar for folks, but the world is going to require and demand that the location become a verifiable thing, where you ideally are able to have concrete cryptographic guarantees or game theoretic guarantees on the location of the data actually being precisely where the system claims it to be. So that means proof of location networks could be pretty valuable. This is a good prompt for an L2, by the way. The whole business probably can exist in terms of an L2 on just proof of location. And so now, if you think of those system constraints or these improvements that might need to happen, and of course, like you can think of a list that's 30 times longer or whatever. And remember, like the cloud took 30 years to do all of this, so we're kind of like visualizing the future, thinking about what must be true there, thinking about how the system must improve and change to get there. And then we plot a course through improvements, selecting some of them, because we can't do everything from the beginning, selecting a few that are going to be very successful in tapping those markets to generate large value flows into the economy. If we can select improvements well, bring those now, tap into those markets, generate significant value flow, then you scale what all of the teams are able to do. You bring a lot more teams into the ecosystem, and then you're able to kind of realize this kind of thing. Cool. So again, market targets, target characteristics, system constraints, and then an improvement trajectory where you're kind of plotting a course through markets. I'm going to skip this because we don't have time, but go to the IPC track to talk about subnets for scaling. This is kind of why we have been working on this for like a couple of years now, and why we're super excited to bring this set of improvements into the network. Cool, that's it. I think we're out of time, so I'll stop there. Thanks.